For these three problems, we're still trying to find the value of each of these expressions. So I'm going to get that unit circle skeleton put in here. Pi over 2, pi, 3/2 pi, and then 2 pi. Hopefully you remember your special right triangle properties. If this is an isosceles right triangle, each of these legs would be square root of 2 over 2, square root of 2 over 2, and then of course, hopefully you remember that because it's a unit circle, we are dealing with the radius of 1. On a 30, 60, 90 triangle, where the smallest angle is pi over 6, the larger angle right there is pi over 3, and we have the side lengths of square root of 3 over 2, across from the pi over 6 is 1/2, and then again the hypotenuse is 1. Okay, so those are the special right triangles. Now we got to figure out where these reference angles are located. Let's pull up this first question, number 12. Cosine of 7/6 pi. So 6/6 would be right here, straight out to the left, but 7/6 is going to be down here in that third quadrant, and this reference angle would be pi over 6. Okay, and hopefully you can use this visual down here on the right here to help you, but across from pi over 6 should be 1/2. Across from the pi over 3 should be square root of 3 over 2, and again the hypotenuse is 1. So we are looking for cosine. So cosine is the adjacent, this distance across the x-axis, and so we have square root of 3 over 2, but it's negative. So we got to keep that in mind. So it's going to be a negative square root of 3 over 2. Okay, let's look at 13. 13 is the sign of negative pi 6. So I'm going to put this over here, and I'm going downward or clockwise pi over 6. So right here is pi over 6. That reference angle, granted I am going negative, and that's okay. So across from pi over 6, you should get 1/2. Across from the 1/3, or pi thirds, you should get square root of 3 over 2. So if you look at these two angles, or these triangles, they're the exact same triangle, just in a different quadrant. And then this hypotenuse would be 1. So now we're looking for sine. So sine is the opposite over the hypotenuse. So the opposite of this angle, pi 6, would be 1/2 over 1, because the hypotenuse is 1. And I'm done, except you need to check the sign. So if I were to use the opposite, because we are using sine, it is going downward. So that is a negative 1/2, and that's your answer. Okay, 14, cosine 5/4 pi. So we're dealing with force, so that is a 45-degree angle. We just need to figure out where it's located. So because we're running out of space over here, I'm going to redraw this. I'm going to redraw the coordinate, and if I had 4/4, I would be directly at pi, because that is pi. But I have negative 5/4, so I'm going in this direction, clockwise, 5/4. So I need to go one more fourth, and that would be my 5/4 in the negative direction. So this reference angle is 1/4, pi over 4. And because it's a special right triangle that is isosceles, it's going to be square root of 2 over 2, square root of 2 over 2. And so my answer is going to be square root of 2 over 2. But you have to figure out the sign. So I'm talking cosine, so that is this adjacent side, which is going to be negative. So I have negative square root of 2 over 2.